Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. So we've got a pump that is pumping salt water from a geothermal system. We want to find the power required to pump the salt water being brine. Okay, so they give us the density of salt water, which is 1050 kilograms per meter cubed. It is 201 meters deep. The flow rate of the pump is 0.4 meters cubed per second, and the efficiency is 75%. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So we got salt water 201 meters deep, and we're using a pump to pump it up to the surface. Step 2, list all the given variables and find the unknown. So we're trying to find the power of the pump. They give us the efficiency. They give us the density of brine. And they give us the volume flow rate of the pump. Step 3, find the formula for the power of the pump. So in this case, it will be the change in mechanical energy for the power, and it is divided by the efficiency of the pump. Step 4, we need to find the formula for the change in mechanical energy. So in this case, it will be the mass flow rate multiplied by gravity multiplied by the change in elevation. So they give us the density of brine and they give us the volume flow rate. So density multiplied by volume flow rate is mass flow rate. And they give us the elevation height. And we assume gravity to be metric because they are using metric units. So it'll be 9.81 meters per second squared. Okay, so this is the formula that we're going to use. Step 5, we just plug and play. Make sure you've got your conversion units to get it into kilowatts. So this is our salt water density. This is the volume flow rate. And we've got gravity and the height, so all of these are given. It's just plug and play. Make sure you have your conversion units as well, and this will come out to 828.16 kilowatts for the change in mechanical energy. So this will be the mechanical power. Step 6, we can now backtrack and solve the question. So it's the mechanical power, or the change in mechanical energy, divided by the efficiency of the pump. So that's the 828.16 kilowatts divided by 75% efficiency, or divided by 0.75. That will give you 1104.21 kilowatts. So note that the frictional losses in the pipe are usually significant, and so a larger pump will be needed to overcome these losses. So when you move water through a pump, you're going to have bends and elbows, and when fluid turns, it will slow down. So that's what they mean as well by frictional losses in the pipe. Okay, disclaimers, the method is correct. However, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video onto your PC just in case this video gets taken down while I follow all copyright laws. Sometimes things just happen. So you can save this video onto your PC using snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. So click on the icon in your taskbar and then open up the program. If it's not in your taskbar, go to your Windows search, type in snipping tool, and then open it up. Click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish. Click the red square in snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.